This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today topic is Eigenvectors of a matrix. Before going to finding the Eigenvectors of a matrix, here let us consider what is a matrix A, what is a matrix I, what is the meaning of lambda. Here let us consider A is a matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Corresponding, let us consider I, that is unit matrix of order 3. We need to consider I3 is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1, where lambda is a scalar. With the help of this A, lambda, I, we need to find out what is a characteristic polynomial and what is a characteristic equation and what are the eigenvalues, that is a characteristic roots. And after getting that eigen roots, then only we need to find that eigenvector. Therefore, according to that characteristic polynomial, with the help of that A lambda I, we need to find out that determinant of A minus lambda I is called the characteristic polynomial. And with the help of that A data of A minus lambda I is equal to 0, if it is equal to the 0, that equation is called as a characteristic equation. Next, coming to point, we are going to discuss that is how to find the characteristic equation, and again what about that standard equation. That is, write the characteristic equation if the matrix is the 3 by 3 such that is a lambda cube minus s1 into lambda square plus s2 into lambda minus s3 is equal to 0, and find with the help of this is the third order equation. We need to get these three roots. That three roots are, let us assume, that is S1, S2 and S3. That is nothing but, here let us consider this S1, S2, S3 is the lambda 1, lambda 2, lambda 3. This lambda 1, lambda 2, lambda 3 are called the eigenvalues. Next, with the help of that, by taking that x is a non-zero vector, corresponding you consider with the help of that box of A minus lambda I into x is equal to 0 by using the Gauss elimination method. That means you solve that equation box of A minus lambda I into x is equal to 0, reduce it to Gauss elimination method. That means reduce it to echelon form of a matrix. That means indirectly by using the elementary row operation. Here where that eigenvector is nothing but x is a solution of the above equation. And similarly, repeat the step, that is a lambda 2 and lambda 3 to find the remaining eigenvectors. This is the procedure involved in the eigenvectors of the given matrix. That means in this totally the given matrix, first we need to find the polynomial. Second one is find the characteristic equation. Next one we need to find the eigenvalue. And with the help of that eigenvalues corresponding lambda 1, lambda 2, lambda 3, with the help of that is box of A minus lambda I into x is equal to 0, we need to get the values that is called as a eigenvectors. Similarly, we need to proceed that is with corresponding lambda 2 and lambda 3. For example, if it is a given matrix A is equal to 5, 0, 1, 1, 1, 0, minus 1, 1, 0, and with the help of this matrix, our concept is we need to find out what about that eigenvectors. But before going to find that eigenvector, we need to find that eigenvalues. Therefore, here the thing is find the eigenvalues and corresponding eigenvectors of the matrix. Therefore, according to, let us consider, find out what is the characteristic equation of the given matrix A. Therefore, that lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Therefore, equation is considered 1. And again, where here S1 is equal to, that is a trace of the matrix A. In previous session, we need to completed how to find the mean values of S1, that is a trace of A. The trace of A is nothing but the sum of the diagonal elements. That means here S, 5, 1, 0. Therefore, the trace of A is equal to, that is S1 is equal to, the value is 6. And similarly, we need to find out what is the S2 value. That S2 value is nothing but that is the sum of the minus of the principal diagonal elements. Therefore, here the diagonal elements are 5. Therefore, first of all, we need to find out what is the 5 minor of the element. That is nothing but you eliminate the row corresponding 5 and again the corresponding column. Then the remaining values are 1, 0, 1, 0. Therefore, that is S2 is equal to that one of the value is one data of 1, 0, 0, 1, 0, 1, 0. And similarly, that second corresponding the 1 minor is also we need to find out. The value is also that is data 5, 1, minus 1, minus 7, 0. And similarly, we need to find out the third value 0, what is the minor of the value. Therefore, after deleting the corresponding the row and column, we need to get that data 5, 0, 1, 1. Then these three sum of the minors of the values is equal to, we get clearly the data of that corresponding 3 by 3, that is 2 by 2, that three values, one is 0 plus 7 plus 5, then the value is 12 is the value. Therefore, similarly, we need to find out what is the S3. That S3 is nothing but the determinant of the given matrix. The data of the matrix is nothing but according to by using the 3 by 3 data, we need to get the value is 8 after simplification of that one. And after getting this S1 and S2 and S3, we need to replace in the equation 1 what we are treated as that is a characteristic equation. And again, by replacing in that S1, that is the first equation, lambda cube minus S1 lambda square plus S2 into lambda minus S3 is equal to 0. Therefore, by solving this equation, that is S1 is equal to 6, S2 is equal to 12 and S3 is equal to 8, then the equation is reduced to lambda cube minus 6 lambda square plus 12 lambda minus 8 is equal to 0. By solving this second equation, then immediately by replacement of lambda is equal to 2, the equation is reduced to 0. That means indirectly here one of the root is lambda is equal to 2 is the solution. Similarly, we need to find out the remaining the two eigenvalues. And by solving the synthetic division, according to we know that how to find the synthetic division, that is with the help of that lambda cube coefficient, lambda square coefficient, lambda coefficient, and again that constant value. And with the help of that, we know that already lambda is equal to, here clearly satisfied one of the root is, then remaining two values when we are going to find out, according to we get it clearly, that is a value is a lambda square minus 4 lambda plus 4 is equal to 0. Therefore, by solving this once again, lambda square minus 4 lambda plus 4 is equal to 0 by using either the quadratic equation or by using similarly the synthetic division or something factorization method. Finally, we got it here lambda is equal to, once again the repeated 2 is the value of the given equation. Therefore, finally, with the help of this the given quadratic characteristic equation, here entirely the values are is equal to lambda is equal to, and second value is also lambda is equal to, and finally the lambda is also 2. Therefore, here finally the lambda is equal to 2 comma 2 comma 2. Therefore, here the lambda is equal to 2 is the thrice, that is the eigenvalues of the given matrix. And next we need to find out that further what is the eigenvectors of the corresponding, this is the matrix. And according to whatever we define the eigenvectors of the matrix, for example, here 2 is the 3 times it is repeated the eigenvalues, then we need to find out that corresponding 3 eigenvectors of the given matrix. For example, if it is lambda is equal to 2, then eigenvectors of the corresponding equation according to that box of a minus lambda I into x is equal to 0. Here x is a non-zero vector corresponding consider. And again by replacement of lambda is equal to 2, that is a minus 2i into x is equal to 0. Therefore, since according to a is equal to, we know that 5, 0, 1, 1, 1, 0, minus 7, 1, 2, minus 2. Therefore, with the help of that a minus 2i, the matrix is by replacement of that is the subtraction of that a minus 2i, the matrix is reduced to like 3, 0, 1, 1, minus 1, 0, minus 7, 1, minus 2. And by taking that x is a non-zero vector, that is x, y, z, and 0 is also that is a 0 column, that is a 0, 0, 0. And according to this procedure, when we are going to finding the eigenvector, first of all, we need to reduce it to that is a Gauss elimination, that is by using the Gauss elimination method. First of all, when we are going to reduce it to Gauss elimination method, we need to write out what is the augmented matrix. The augmented matrix is nothing but the collection of the matrix of B and again the respective that is a 0. And where here B is equal to box of that is A minus lambda I. Therefore, here it is A minus lambda I is equal to 0 is nothing but 3 0 1 1 minus 1 0 minus 7 1 minus 2. The last column is also 0 0 0. And again this matrix we are going to reduce it to that is a echelon form of a matrix by using the row operation. While we are applying like R1 2, that means interchange of that is a R first row and also the second row, then automatically this will changes to 1 minus 1 0 3 0 1 and minus 7 1 minus 2. The last column is there is no changes, that is 0 0 0. Once again, while we are going to apply that is a R12 of minus 3, that is nothing but R1 minus 3 into R2 with the help of that elementary row operation. The first row is there is no change 1 minus 1 0 0. The second row is changed to 0 3 1 0 and the last row is by replacement of R13 of 7, that is nothing but R1 plus 7 into that is a R3. Therefore, that minus 7, 1, minus 2 is changed to that is 0, minus 6, minus 2 and 0. And this is also not a echelon form of a matrix. Once again, while we are applying R12 of minus 3 and again R13 of 7, the matrix is reduced to 1 minus 1 0, 0 3 1 0, 0 minus 6 minus 2 0. And it is also not a standard form of that echelon form of a matrix. Once again, when we are going to divide, that is R2 divided by 3, the matrix is reduced to that 1 0 0, 1 minus 1 0, 0 1 1 by 3. The last row is that is 0 minus 6 minus 2. Once again, we are going to apply R2 plus 6 into R3. Then automatically the reduced to like R2 row is reduced to 1 minus 1 0, 0 1 1 by 3 into 0. The last column is changed to like 0 0 0 is the value. Therefore, it is clearly satisfied the echelon form of a matrix. Why? Because it is according to that upper diagonal triangular matrix is clearly satisfied. Therefore, by using if it is a echelon form of a matrix, by using this echelon form of a matrix, now we are going to find that values are x comma y comma z. But here, according to if it is echelon form of a matrix, the number of non-zero rows is equal to that is here 2. Therefore, rank of this matrix is equal to 2. Therefore, according to the rank of B is also that is 2. It is less than n. According to the concept of the rank of A is equal rank of AB is equal to rank of A is less than n, the condition is said to be infinite solution. Here, because here n is equal to the number of rows are 3, but here that according to that augmented matrix the rank is 2. Based upon this condition, it is the number of solutions are that is a 3, that is a infinite many solution. Now we need to find out what about that infinite solution. Therefore, by taking that here the equations are x minus y plus 0 is equal to 0, 0 plus 1 plus 1 by 3 into z is equal to 0. By using this equation, according to by taking that, the first equation is reduced to x is equal to y, and again that z is equal to t is a value. Therefore, by taking here that z is equal to that is a t, where t is any real number, by taking that z is equal to t, then automatically x is equal to minus t by 3 and y is also you obtain that is a minus 1 by 3 into z. Therefore, y is also that is a minus t by 3. Therefore, this is the conclusion of the eigenvalues of the given matrix lambda is equal to 2, the corresponding eigenvector that is x is equal to treated as that is small x, y, z is equal to one of the eigenvalues is the that is a minus t by 3, second is the value is a minus t by 3 and third is also t is equal to t by 3. Here for all values of t belongs to any real number. For example, by taking that consider t is equal to 1, the value is nothing but that is minus 1 by 3. The second value is also changed to like that minus 1 by 3 and the third value is nothing but changed to 1 is a value. Therefore, that finally conclusion of this eigenvalue lambda is equal to 2, the corresponding eigenvector that is x is equal to minus 1 by 3, minus 1 by 3, 1 is a value. And again, similarly, for example, you consider one other example, find the eigenvalues and eigenvectors of the matrix A is equal to, here where the matrix A is equal to 3, 1, 4, 0, 2, 6, 0, 0, 5. While we are observing in this given matrix clearly which is satisfied, that is upper triangular matrix. Why? Because according to the definition of the upper triangular matrix, the below the diagonal elements are the 0. Here clearly satisfies, that is a given matrix is a upper triangular matrix. Therefore, here the eigenvalues are the diagonal elements. Therefore, here eigenvalues of the diagonal elements are here 3, 2, 5. And now we need to find out what is the corresponding eigenvectors of lambda is equal to 3, lambda is equal to 2, and lambda is equal to 5. And first of all, we are going to find out first eigenvalue, that is the corresponding eigenvector. According to the definition of the eigenvector, that is a minus lambda I into x is equal to 0, where A is the given matrix, lambda is a eigenvalue. Therefore, with the help of this matrix, A minus 3i into x is equal to 0, let us assume that B is equal to A minus 3i. Therefore, the matrix is changed to like 0, 1, 4, 0, minus 1, 6, 0, 0, 2, where x is a non-zero vector, x, y, z, and 0 is also corresponding column vector consider 0, 0, 0. Therefore, according to by that is a given matrix consider augmented matrix is nothing but the collection of the B matrix and column matrix then add within the matrix. And again, now our concept is this augmented matrix is reduced to echelon form of a matrix. That indirectly, that is a Gauss elimination method, you need to find the solution. And according to the Gauss elimination or echelon form, by using only the row operation, we should not apply any column operation. Therefore, in this equation, in this matrices, we are applying R12 of 1 is nothing but R1 plus, that is R2. By adding that first row and second row, then first row is there is no change and third row is also no change. The second row is changed to 0, 0, 10 and also 0. Therefore, once again, when we are observing here, it is not a echelon form. Why? Because that R2 and also R3, the last value which is existed, the 10 and also 12. Therefore, we need to change either 10 to 0 or 2 to 0. That is by using the operation of, while we are doing R2 3 of minus 1 by 5, that is nothing but R2 minus 1 by 5 into R3, then the matrix is reduced to 0, 1, 4, 0, 0, 10 and last value is also, that is row is a 0, 0, 0. Therefore, this is the matrix is the clearly considered echelon form of a matrix. According to this echelon form of a matrix, here also the number of non-zero rows are 2. Therefore, the eigen rank of a matrix is also 2 only. Therefore, here first column is, let us consider x, second column is y and third column is z, and corresponding this equation, if it is treated as, that is x is equal to t, then for all values of t belongs to r, by applying the back substitution method, that is 10z is equal to 0, then automatically z is also 0. From that first equation, that is 4y plus 4z is equal to 0, then y is equal to minus 4z. Therefore, conclusion of here, lambda is equal to 3, that x is equal to x, y, z is nothing but one of the value eigenvector is a t, 0, 0. Because of z is equal to 0 and automatically y is also 0. You assume only that x is a, t is any real number. And therefore, by taking here also t is equal to 1, therefore that 1, 0, 0 is the eigenvector corresponding lambda is equal to 3. This is the clear example for the eigenvector corresponding to the eigenvalues of the lambda. And similarly, now we are going to find out that is a lambda is equal to the corresponding eigenvector. Therefore, for example, lambda is equal to the eigenvector is nothing but by the definition a minus lambda I is equal to 0, where here lambda is equal to 2. Therefore, the augmented matrix is changed to 1, 1, 4, 0, 0, 6, and again the last row is 0, 0, 3, 3. And again, now we need to find out by using the elementary row operation reduced to echelon form of a matrix. Same here also, by using the back substitution method, that y is equal to t, because of that last second row, that is a z is equal to 0. If it is a z is equal to 0, then automatically the first equation is a x plus y plus 4z is equal to 0 is changed to x plus y is equal to, that is a 0. While we are taking that y is equal to t, then automatically x is equal to minus t. Therefore, here conclusion of that eigenvector, the corresponding eigenvalue of lambda is equal to 2 is equal to, that is a minus t, t 0, where by taking the t is equal to 1, it is a clearly obtained minus 1, 1, 0 is a eigenvalue. Now we are going to find out that is a corresponding lambda is equal to y, that is a corresponding eigenvector. And here also, for example, lambda is equal to 5, the corresponding eigenvector is with the help of the characteristic equation a minus lambda I into x is equal to 0. Here also a minus 5i into x is equal to 0. Therefore, the augmented matrix is considered minus 2, 1, 4, 0, 2, 0, minus 3, 6, 0, 0, 0, 0. Now, we want to find out reduced to echelon form by our way of thinking. That is nothing but by change it to, that is reduced to echelon form of a matrix by using the row operation. And finally, this is we obtain, that is echelon form of a matrix by using the elementary row operation. Therefore, here also, that is a number of non-zero rows is equal to 2. Therefore, according to it is a number of non-zero rows is equal to 2. The rank of a matrix is also 2. By using the definition of the rank of a matrix, here the number of non-zero rows is equal to, that is less than the given number of rows. Therefore, here also the number of solutions are like infinity. Therefore, let us assume that z is equal to t, then automatically that y is equal to the 2t is also obtained clearly. And again similarly, here x is equal to, we obtained with the help of the equation minus 2x plus y plus 4z is equal to 0. That is 2x is equal to y plus 4z. While we are already assumed that is a z is equal to t and y is also 2t, therefore 2x is equal to, that is a clearly 6t, therefore x is equal to finally that is a 3t. Therefore, here thus the eigenvector of the corresponding to the lambda eigenvalue lambda is equal to 5 is x is equal to xyz is equal to 3t, 2t, t for all values of t belongs to R, t is a R. Therefore, this is the clear the solution of the eigenvector, the corresponding lambda is equal to 5 is 3, 2, 1. Therefore, the conclusion of that lambda is equal to, that is a 3 is the eigenvalues. Similarly, here clearly mentioned that the eigenspace that is for lambda is equal to 5 is E3 is equal to 100 and lambda is equal to 2 is equal to minus 110 and lambda is equal to 5 is a 3 to 1. These are the three corresponding eigenvectors of the given matrix. For example, you may consider this is the matrix to find the eigenvalues and eigenvectors of the given matrix. That is, the matrix is the 8 minus 4 2 2 with the help of the characteristic equation, that is delta of a minus lambda is equal to 0. Therefore, the equation of the characteristic equation, that is a lambda square minus 10 lambda plus 24 is equal to 0. This is without using the shortcut method, that is a lambda cube, that is a lambda cube minus s1 into lambda square plus s2 into lambda minus s3 is equal to 0. This is by using the determinant process. While you are using the determinant process, this equation is a lambda square minus 10 lambda plus 24 is equal to 0. Here by solving this lambda is equal to the equation, you obtain clearly 4, 6 only. Therefore, once again we need to find out with the help of the lambda is equal to 4, the corresponding equation is a 4 minus 4, 4, 2 minus 2, that is a 0, 0. By solving these two equations, we obtain that lambda is equal, that is x1 is equal to 1 and x2 is equal to 1 also. Therefore, this corresponding eigenvector of the given matrix lambda is equal to 4 is, that is 1, 1. And similarly, while we are doing that lambda is equal to 6, the corresponding eigenvector is a, with the help of the characteristic equation, that is a minus lambda I into x is equal to 0. The solution is by solving that echelon form of a matrix. Therefore, here also the eigenvector is, you obtain that 2, 1. Therefore, here similarly, one other example, by using the determinant process, that is to find the eigenvalues and eigenvectors of the matrix, that is where the matrix A is equal to 2, 0, 1, 0, 2, 0, 1, 0, 2. Therefore, the delta of a minus lambda is equal to 0. By solving the determinant process, we need to get, that is a lambda cube coefficient, lambda square and lambda. By solving these three equations, that is a lambda cube equation, that is order of the third order, if we get clearly, that is the three roots. Here the three roots are 1, 2, 3. Whether these eigenvalues are correct or wrong, that you have to check it for our understanding, here lambda is equal to 1, 2, 3. The sum of the eigenvalues is equal to the trace of the matrix. Here, the sum of the eigenvalues is equal to 1 plus 2 plus 3. Therefore, the trace of the matrix is also clearly satisfied. 2 plus 2 plus 2 is equal to, that is 6. And other confirmation, the product of the eigenvalues is equal to the determinant of the matrix. That is nothing but 1 into 2 into 3 is equal to, the det is also 6. You obtain that clearly. And again next, now we are going to find out the eigenvectors of the matrix corresponding lambda is equal to 2. For example, it is a lambda is equal to 1. The corresponding eigenvector is a 1 0 1 0 1 0 1 0 1. By solving that, a minus lambda I into x is equal to 0. Finally, by solving this equation, the eigenvector is equal to satisfied minus 1 0 0 1. And similarly, we need to find out corresponding lambda is equal to 2. What is the eigenvector? Similarly, here also that with the help of the characteristic matrix, that is a minus lambda I into x is equal to 0. By using this as a process, we obtain that clearly that eigenvector is a 0 1 0. And similarly, we need to find out that third eigenvector corresponding lambda is equal to 3. Therefore, here also by using the characteristic equation, by solving this here, also we obtain that eigenvector is a 1 0 1. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.